This week we're going to sea to see what the seals can see.
Really?
Yes.
And what can they see?
An enormous turbine.
We're going to find out whether sea life and sea machines can happily coexist.
This is a harbour seal, and this is what we're looking for in the data.
Shona takes control of this monster.
Paul gets up close to this beast.
Oh, wrong room.
And Zoe gets attacked by a giant Iron Man. Hello and welcome to another scenic Glasgow location. Behind us is a Victorian ship. For a long time we've known the power of wind at sea, but we're getting better than ever before at harnessing wind power.
Yeah, now the year 2020 won't be fondly remembered for much, I'd say, but it was at least a very windy year. Apparently in 2020 we produced 50% more wind power than 2019.
And one of the best places to have a wind farm is at sea, where there's lots of wind and also lots of space. But how do you look after it? Well, Paul Carter's taken the plunge to find out.
No, this isn't some kind of sea monster, but an autonomous machine which aims to perhaps make working at sea that little bit safer. With an ever-growing demand for renewable and sustainable energy sources, the infrastructure that provides that energy is becoming increasingly critical. Now, at present, those facilities are often maintained by human divers, working in challenging and hazardous conditions. But here at Heriot-Watt University, they're developing underwater robotic solutions to help take the strain. And they've come up with this, the Orca autonomous drone.
We've got a scanning sonar, a mechanical scanning sonar, and that can see all of the structures and items around the vehicle at a long distance. We've got an acoustic modem. This means that when we don't use the tether, we can communicate with the robot using sounds underwater.
And how does it move around in the water? Is it with these propellers that I can see here on either side?
So it uses, yes, there's 8 thrusters that are used, and it can move it in all 6 directions. So you've got forward, backwards, left, right, up, down, and then you've got roll, pitch, and turn.
Oh wow, so it's pretty manoeuvrable then?
Yes.
All of this technology allows the device to work autonomously, planning its own route to fully scan a structure with little human intervention.
So the system that we have will continuously explore the unknown areas and see what comes next on the structure, but we can also suggest positions to it. It takes the images from both cameras, the stereo cameras, much like how we perceive depth, and it can use this data to create a 3D model of the structure under the water. These can be viewed by the engineers and by the surveyors to detect problems early when they're able to be fixed easily and cost effectively.
Currently, 80% of the cost of offshore wind is spent on maintenance through manned ships and technicians to do inspection and repair. So it's easy to see how this robot could cut costs. But robots may also solve a practical issue as wind power expands.
So in the future we're going to have not hundreds but tens of thousands of offshore wind farms. If you've got 10,000 wind turbines to inspect, and if you have one person, one vehicle, you need 10,000 pilots, and you don't have them. They don't exist. We're going to need to replace or change the way we do things so that we can have several pilots monitoring tens or hundreds of those vehicles. So we need small-scale robotic fleets that are able to navigate these large farms and inspect and repair them remotely from shore.
What's really fascinating is how autonomous robots like this could allow for further innovation, solving problems like the expansion of wind farms held back by the sheer practicalities of people. It's easy to imagine how undersea cables, renewable structures, and even boats could be maintained remotely. So the technology seems to be there. It's now over to the businesses to make sure it's viable.
It's not just under the water where there's innovation. This is a boat with no people on it. Also known as an uncrewed surface vessel, which can take to the seas to inspect projects in far-flung locations which are difficult to get to.
Autonomously operated vehicles like this are really important for the environment because they reduce fuel consumption and they also mean less people need to go offshore to do the on-site inspection. This is the EROV, it's the electrical remotely operated vehicle. What it's doing is it's launching into the water, it's filled with sensors and cameras, and it'll look at high definition images, feed all that stuff back via satellite to the guys in Aberdeen. By deploying these types of vehicles, there's a potential to reduce fuel consumption by as much as 95% in comparison with conventional ones.
Autonomous vehicles are marine robots, really. So all of our lives are going in towards digital and remote and autonomous. So this is nothing different. This is just the transformation of the offshore marine industry into a fleet of robotic vessels that can go and collect some really cool, very significant data that we need.
The firm collects and analyses geological data at land and at sea.
We're also looking to expand our fleet. This is obviously the Fugro Orca being the first of a fleet of 3 or 4 that we expect to have by the end of this year. And then we're looking to expand the fleet with larger vessels that are capable of conducting operations in the even more hazardous environments with greater weather endurance limits and also the capacity to be at sea for that much longer.
All clear to move off? Okay, all good to move off.
Here in Aberdeen, where the control centre is, the team on dry land connect with the technology which is out at sea.
We have visual data from the cameras. So if we were on a wind farm, as you see the wind farm coming up from the sea, it's actually a big structure underneath that goes to the seabeds and attached there. So we'll be looking at the fixings to the seabed, the metal structure itself. They're all connected with power cables, so we'll also inspect power cables, make sure they've not been damaged by fishermen. The RV also has sensors that can make sort of 3D models of the seabed, so we can also check around the base of the structures, and we can follow the pipelines with these as well.
Remote and autonomous technologies will play a vital role in the future of the maritime sector.
This company hope to expand their fleet in the coming years to play a part in a safer and more sustainable future for essential work that needs to take place out at sea.
That was Paul and Shona all at sea.
Now, with more and more tech being used above and below the water, have you ever wondered how it affects the creatures that live in it? Well, Harriet Bradshaw's been to see some technology that's trying to find out if new tidal turbines are harming sea life in their homes.
The challenge ahead.
It's absolutely terrifying, yeah, because this thing's going to go down and it's going to get plugged in and it's going to work or it's not going to work.
This is about balancing technology with nature.
So in this particular area, we've lost about 85% of our harbour seals.
So how do we protect them whilst quenching our thirst for clean energy?
Tidal has a role. The wind doesn't always blow, tidal always keeps going.
Perhaps this monitor is the answer. We're at Nigg in the northeast of Scotland.
It's about the length of a bus.
Crikey.
Yeah, and the blades go around.
All underwater
all underwater, so vessels pass over the top. We're 8 metres underwater, the tip of the blade.
This tidal turbine is being prepared to go in waters with some of the strongest currents in the world.
Let's have a little bit more of a look, eh?
And underwater, that power will push these blades around to make renewable energy. But tidal power isn't yet as developed as wind power.
barnacles on there?
Those are barnacles on there.
Barnacles on it. So this
barnacles.
one's already been
Yeah,
underwater.
this has been in the water for about 2 years. This turbine does get barnacle growth on it, and then that becomes food for fish. During slack tide, there are fish around these turbines,
Which would attract these little
which
mammals.
would attract predators. So little feeding grounds. And the question is then, as the flow increases and the turbine goes into production and the blades spin faster, do the fish remain? Do the predators come back? Do we have an impact on those predators? And is it a detrimental impact?
And it's crucial to develop these kinds of turbines in a way that doesn't harm these creatures, which are already under threat from other factors.
And in the past, sort of early 2000s, between Orkney and the north coast here, we'd have had about 9,000 harbour seals. And unfortunately, over the last 10, 15 years, we've lost about 85% of those animals. Oh, yeah, we have one, see on the end of the slip down here. Yeah, so some of the initial research was actually designed to look at how animals are actually using some of these habitats, how they're using these highly tidal areas around the north coast of Scotland. And we are certainly seeing that these areas do seem to be important for harbour seals around this area. And indeed, we do see animals coming relatively close to the turbines. But it's really that fine scale behaviour that we're really interested in. What do animals do when they really come close to the turbines?
To answer this unknown, sinking a monitor next to a turbine might be key.
So Douglas, this is going to be submerged underwater. Can you take us through the technology here?
That's right, of course, yeah. So the two main sensor technologies we've got on it are the active sonars we're using for tracking seals primarily, because they don't make much noise underwater. So these send out a very, very high frequency ping, which is too loud for the animals to hear and be disturbed by. Then they listen for the echo and they can build up an image of exactly where the animals are around the turbine. Then the other sensor that we've got on it is underneath this protective housing here, which is the passive hydrophones, which are listening to the sounds that the animals make, and we can use those to pick up the sounds of porpoises and dolphins.
I've also noticed this, Douglas.
Yeah, then there is the great umbilical cable. So the optical fibres that are bringing the data ashore are actually about as thick as a human hair.
Wow, okay.
But they're inside all of this with a whole load of steel clamped in there too, just to make the thing heavy enough to lie on the seafloor.
But no one said this was going to be easy. The journey to the far north of Scotland begins. John O'Groats. It's here that the monitor will be sunk underwater and installed on the seabed next to the turbine.
When it's connected, the signal will run through underwater cables to this substation here.
This is a test deployment we did a couple of summers ago in another tidally energetic area on the west coast of Scotland. You'll see that there's some moving targets down here. These are small fish that we see quite close to the sonar. And what we see here is this bright target coming in. This is a harbour seal, and this is what we're looking for in the data once we're deployed.
But this was just a test. Inside the substation, Douglas and Gordon are waiting to see if it's going to work more permanently.
Douglas, 5 years in the making, how are you feeling at this point?
A little bit nervous, as always. You know, we test and test and test. This equipment's about to go down into one of the harshest marine environments in UK waters. We're hopeful that we'll be successful, but we'll go and see.
It's 5 a.m. The ship is out at sea. We're here on land waiting for the signal. And that's because there is only a certain number of opportunities for the equipment to be submerged underwater and onto the seabed because of tidal conditions.
But there's a delay. The turbine must be installed first, but a problem is holding things up.
They haven't deployed our equipment yet, but it will happen today for sure. But as anyone who's worked at sea will know, nothing ever goes quite according to plan.
But the moment finally arrives. Remember that umbilical cord? The power cable that also sends data ashore. Well, what we're watching here is it being plugged into a subsea hub. This will give the sea mammal monitor power, and this is a crucial moment. Is it going to connect? is it going to switch on? And after years in the making, it's not good news.
Everything went together, but nothing came to life.
But they've not given up.
This is an easy little move to rectify this. Thank you very much.
Months later, they sort out the power supply and bingo.
What a day. It's been 5-6 long years of work. It's on the water, it's working. I could not be happier.
So we're all overjoyed. We're collecting data, and we hope to carry on collecting data for the next year. Touch wood.
That was Harriet, and back on dry land, it's time for a look at this week's tech news. Netflix has laid off about 150 staff just a month after it announced it was losing subscribers for the first time in a decade. The redundancies will affect around 2% of its North American staff. Meanwhile, streaming rival Disney Plus has added almost 8 million new subscribers worldwide, bringing it to a total of 138 million users, though still quite a bit less than Netflix's staggering 220 million.
Netflix is actually spending less in terms of trying to get those subscribers than Disney is at this point, but it is proving to be very successful. They are going into about 53 to 54 different markets worldwide.
Researchers from New York's Cornell University are looking into how a massive robot can be used to make the construction industry greener. The robot is being used to 3D print construction materials such as concrete without having to use costly and time-intensive molds. And Apple has announced a range of new accessibility features for its devices, such as live captions that will transcribe calls, videos, or even in-person conversations on the fly. The features are due to be introduced in the US later this year.
None of this is real. The grass, the sky, the trees, it's all computer generated on this white light smart stage. See, here at Portsmouth University's multi-million-pound brand new centre for making all things virtual reality. Come with me, I'll give you a quick tour. The centre also has motion capture, but to show you that, I first need to get into one of these. There are 48 cameras in this room tracking my every move. This studio's already been used by the Royal Shakespeare Company to create a digital production of A Midsummer Night's Dream. With traditional motion capture, you couldn't see what you were doing in real time, but now you can. This makes it easier for actors to assume the roles of their characters in videos, movies and computer games. They can see what they're doing. But this sort of kit requires time, space and expertise to operate. It's not generally easy for smaller businesses to access. VR can be a lot of fun, and it is. But there's also a serious reason to consider using it professionally.
Sustainability. For example, I was due to give a keynote address to University of Michigan. Normally I would have flown over there, but now I'm doing it from our Smart Stage facility here. So that's a significant carbon saving over flying just on that one flight alone.
This is your baby, isn't it?
Absolutely. I have to admit, it's a little bit like a fourth child. First time you put someone in a headset and you see that smile, it's just magical.
But that magic can be hard to maintain when there's one crucial element missing, your sense of touch. Are you really fighting a fire if you can't feel the heat? This Tesla suit, no relation to the car, aims to fix that with dozens of sensors that can be programmed to make your skin tingle in every sense. There's one here in Portsmouth, although it's not yet ready for me to try out. But if people are put off VR by the clunky headset hardware, are they going to want to stick on a bodysuit as well? Master reality. And there's another challenge facing the extended reality market that this centre aims to directly address. Some say there simply isn't enough good content to keep people interested. Isn't that right, Tuong?
There's still limited amounts of content, right? In that sense, it's like subscribing to a cable's TV service and only having 3 channels available. And even if you're really excited about those 3 channels have, maybe 3 hours worth of programming per day. So that's a challenge in terms of getting people to adopt.
Camera rolling.
Meanwhile, in this studio, you can be videoed in 3D. It's called volumetric capture, and once you've been recorded, you can end up anywhere. Oh, wrong room.
And apparently Zoe's still trying to find her way out. And that's the thing about this latest generation of immersive tech. It really is immersive, isn't it?
Yes, we've both gotten lost in a virtual world or so.
Yeah, and we're starting to see proper performances taking place in them too.
Oh, like the time you were in a VR Midsummer Night's Dream.
I only had a tiny part.
The only thing is that these performances can be quite exclusive because you've got to have the right equipment to be able to enjoy the experience. Well, now, a show that's trying to be accessible to anyone on anything. The National Theatre in London has long been one of the city's best respected stage venues. But now, here at its studio, it's also been working hard on its digital offerings. Originally just a virtual reality experience, All Kinds of Limbo is a celebration of multicultural society that had run alongside a stage show. But now it's opened up a whole new genre of entertainment. The idea that the same show can be watched at the same time, anywhere in the world, in a variety of formats depending on what kit you have available to you. So that could be in VR, on a normal computer screen, or in augmented reality via a phone or tablet. It's quite nice I can make it appear in the room, but I think I'd appreciate it a lot more if I was at home and it was appearing in my living room. I want to dance, it will make the iPad move too much though. That was really immersive, and it was lovely to be able to move around the performance, see it from all angles, make it bigger and smaller. It was a little bit heavy to hold this tablet because it's quite large, but of course most people are probably going to be doing it on a smartphone anyway, and you can rest it on a table and then just flip it a bit for the right angles. For me, it did feel more natural and engaging in its original VR format though. I definitely feel more immersed here.
We had Nubia, our actress, in our volumetric capture studio. We recorded her performance, with about 120 cameras all set around her, and we then processed that through some technology that allows us to create a three-dimensional hologram of her performance. And from that one asset, we then put that into VR, so you can experience that. It feels much like meeting somebody when you put on a VR headset, and it feels like they're there right in front of you. And then AR, it's a sort of portal onto that experience. It's not quite the same, it doesn't feel the same. And then the desktop experience, which I think we can all see sort of plays really as a sort of enhanced screen.
The idea here is about being able to democratise the ability to watch performance. So if you don't have a VR headset, not many people do, or a great phone, but you do have a decent computer or laptop, then maybe you want to watch it on one of them, and you'll still have the ability to make it immersive, to be able to move around the space.
Take a look at my spice rack. I think what we're exploring here is most definitely a new future. It's not the new future. We will never ever replace live performance on stage. However, with the technologies that are available and with the expectations of audiences continuing to change over time, what is great is for us to be able to bring National Theatre to new audiences in new ways.
So whilst the aim here is far from replacing theatre, it might just add something extra and an experience that can be enjoyed by many more.
And that's it for this week's edition of Lyra Dances in VR Goggles.
I'll do it off camera next week.
Would you mind? Thank you very much. Anyway, that is it from us for now.
We will be back very soon.
Thanks for watching.
Bye-bye.